next presentation we're going to have is actually by Eric Probst and Cathye Pendley of Lama Software. And I'm really pleased to be able to have one of our customers present on how they use their OAC, and for that matter, some machine learning to look at how they analyze check acceptance and their automated clearinghouse payment solutions. Certity has been doing this for a while now, and they will be tag teaming between Eric and Cathye, and then I think they also have another person, Jason, sharing what they've done. So we're really looking forward to them sharing with us how they're using that technology to analyze fraud and other types of related activities. So with that, I will turn things over to Eric and Cathye. We look forward to you guys sharing what you have.
Thank you, Dan, and thank you for giving Certity the opportunity to present here. Can everybody see my screen?
Yes, we can see it.
Awesome. So I'm going to be joined by two of my colleagues today, Chris Jacobson, he is the manager of fraud investigations, and Jason Hosler, who is the manager of our data science team, along with me and Cathye. On the agenda today, we're going to talk about who Certity is. I'm sure a lot of people don't know who we are. Our OAC experience. We're going to talk about our venture into machine learning, and then a use case with Apex and our investigation team. So who is Certity? Well, when you think of this, you probably think of the dinosaur of the payment industry. You probably think checks should be in a museum. Well, in 2019, Certity decision 378 million checks worth $160 billion. And during the pandemic, the US Treasury released stimulus checks. This year, we cashed 1.9 million for $2.3 billion for people. So it's a pretty significant payment instrument here. So what is Certity? Let me just break it down for you. If you go into a retailer and you write a check to buy some goods and services at one of our merchants, they will swipe it through a machine. It will come to us. We will make a decision and give them a recommendation either to approve or decline. If they approve and they take the check and the check goes bad, the merchant doesn't want to spend the time to go out and collect this. So they let us do it. So we go out, we take the risk for the check and we go out and collect it for them. We give them the best decisions we can. We have over 4,000 merchants, 23 of the top 25 retailers, over 300,000 locations. That includes instant funds, which is where you can take your paycheck for the underbanked, who can go to a retail location and cash their paycheck, or government check. The heart of the operation, though, is the risk management team. And that is made up of our data science team, our risk analytics, and our fraud investigations. Our data science team basically gives us the tools that we need. They create analytical scoring models, kind of like credit scores. They've been working with neural nets and random forest analysis. The risk analytics team uses those tools to approve as much good volume as possible and prevent as much fraud as possible. It's a slippery slope. We try to approve as much as we can while blocking those that we think are bad. We don't know if they're bad for sure, but we do our best. We also do customer presentations and control recommendations, which I'll get into after. And then finally, we have our fraud investigation team, which works with law enforcement to track and arrest organized fraud groups. And believe me, there's a lot of them who take us for a lot of money. So they are very important to the operation. But let's get into the customer presentations. Certity is a legacy Hyperion interactive reporting company. We've had it since 2002, 18 years. So basically, Hyperion interactive reporting is take the data, dump it into Excel. You get a wall of numbers that we presented to our customers regularly. With Oracle, now we can put in these graphs that show us trends and show outliers. You can also put in the numbers, but it also makes it a lot more visually easier on the eyes, I guess you could say, to point out the trends. So it's been a game changer for us there. A real case scenario is back in the spring, I was working with the state of Washington who was getting hit by fraud, almost like $500,000. I created some visualizations for them to show them where their checks are being cashed. And it was kind of a A jaw dropper for them. Yeah, of course, you would expect most of their checks to be cashed in Washington and surrounding states, but would you expect your checks to make it all the way to Maine? So we decided to give them some visualizations, which they present to their executives on a quarterly basis. Our OAC implementation. I've been on many presentations for Oracle. What I've heard over and over is user acceptance, right? So like I said, we've had almost 2 decades of Hyperion interactive reporting, and you can imagine all the embedded processes we have in there as it pertains to risk. So there was plenty of skepticism about changing. And part of that skepticism was because of the training. The way we started out was YouTube videos, Udemy classes, working together, trial and error to get everything to go. We worked with Oracle, who took a lot of time to meet with us, so much so I felt like we should have been on the payroll at times. You know, I like to thank Matt Chang, Ben Arnoff, who I think is on the call, Laura McKegney, Charlie Berger, and others, Danielle Chickaswamy. The Oracle team helped us, and you pick up bits and pieces. And what we learned were we got to data flows. And data flows are a little more technical than the risk analysts are used to. You know, we tried our best, but we needed some help. And we had talked to Dan and Tim Blamis in Miami back in January, and we continued to talk to them through the spring. We wanted to get our feet under us before we actually partnered with Blamis Software Solutions, excuse me. And when we did, we had them come in and look at our data, and they introduced us to subject areas. And subject areas to us were like, whoa, blown away. And what I like to do is let Cathye share what she saw with the subject areas and our potential. You want me to go through the slides, Cathye?
Cathye, we can't hear you.
Okay, I'm sorry. Can y'all see my screen? I'm sharing. Yes. Can y'all hear me now?
Yes.
Yes, we can hear you.
And you can see, can you see my screen that shows a risk analytics subject area?
Correct.
Okay, good, perfect. Then let's go ahead and get started. Like Eric said, we came out a couple of months ago to try to help with the OAC implementation, and we helped them with some visualizations. But one of the things that became apparent was they were having some performance problems. So we started looking in and seeing the things that they had done, and most of the things they had done had been built on data sets, and they hadn't taken advantage of the RPD or the modeling or subject areas. So while data sets are great, data flows have their purpose, it's not there to replace an analytics data model. So that was one of the things we noticed. So we started doing a little bit of research, and the things that we found were the users were having problems with performance issues. It was not only the users, they were also running queries on the back end that were causing performance on the data warehouse and people getting calls saying, okay, you got runaway queries that's impacting the database. It would be reports taking a while to come up, as well as whenever you click to filter on a chain or a city or something like that, it would take a while for that list to come up. So as we looked at the things we found, they also had some complex data flows. And one of the big things that we noticed were that due to the limit of the data set sizes, they had to filter down their set. So you look at here and they would filter it down by chain. So that's another issue that we saw that, hey, maybe modeling can help that. And then one of the other things, one of the final things that we really noticed was also that they had a lot of calculations within the projects themselves. So what they were doing is they had these are really good calculations and they're needed, but they're more difficult to share across the organization. So having one place that everyone could share them and all the calculations would be the same, that would be ideal. And then the second thing we noticed when looking at the calculations, you see you have a lot of 2019, 2020 volumes, and then you have the difference. So anytime you change 2021 gets here, you're going to have to change these calculations in order for them to go into the next year. So that was quite a bit of maintenance. And with that, I'd like to go into just a quick demo. I have these slides here for you to take away if you download the presentation, but I would like to go into just a demo and kind of show you what they had before and how we changed. You'll notice here when you look at it, we didn't change the format of the reports at all. All we did was we changed the back end and how we built the data. So if you look here, this is the original forecast that was built by Certity. Very good. I mean, just what you'll notice here, it's a very good application that works. It just has some performance issues and things going on. But the one thing we noticed is it had two data sources that it was coming from. They were going straight towards the data tables. That's this little icon here, so it's going straight towards tables. And if you look at the table, you have all the facts and attributes are in the same table. So what happens here is we have like the transactions. These are transaction tables, so these are all the checks that are written. I think there was about 114 million rows in this table. So what you end up here is when you go to filter, like on this service type, if you go to filter on it and the data isn't cached, it could take up to maybe a minute to come up just because it's having to go against 114 million rows, as opposed to if you build a table, a dimension table, it would only go against the 5 to 10 values that you have in that dimension table. So that runs much faster. We also noticed that there's also, you have the time. You have hard-coded times of 2019 and 2020. As we talked about before, these are hard-coded dates in the filters. So we know that each year you're going to have to change this. And these were hard-coded months as well. So each month you need to go in and change the month. And if you look here, like I said before, they have all these calculations going on here. So what did we do? The things that we did to take advantage of this is to go in and first off, we created dimension tables. So you see here now we have all the attributes are sitting within the dimension table. And so when you go to select on one or filter on one, you're filtering on only the amount of values that are in that dimension itself. So instead of 114 million, you're doing 5, 10, 50,000, depending on the number, but not anywhere near as large as going against the fact table. And we took all of their base facts. If you see here, all their facts have nothing but facts on it. It's a lot longer of a list because we also pull the calculations in. So if you look at this, all of this now is stored within the table and not in my calculations area. And then what we also did is we took, instead of creating 2019 and 2020, we were able, by going and using the repository and subject areas, we were able to go in and create prior year, taking advantage of the time series analysis. And we also created a summary table. So now, instead of going off of the 114 million rows, we're going also, when we're building reports, we're going off something significantly less. So the reports are coming up quicker. The analysis are coming up quicker. We also created some rolling years. And this allows us to take the current year and then prior year. So if the current year is 0, prior year is -1. So as the years go on, we built that within the model that they can go and select, and it will always be 2021. You'll get 2021 and 2020. So we created all of these which allow for faster performance and less maintenance on the projects and analysis that they build. Okay, so let's go back and what did all this accomplish? So if we look at it, what the results were is Certity ended up with more common calculations that they can share, and they are defined one place, so it should be standard across the organization. The future maintenance, yeah, it's not going to be as much since we're not hard coding things within the project. But the big difference is people are able to pull reports, pull these analysis off of this proof of concept, and get the data back fairly quickly. I think Eric said he pulled 23 columns for all of his chains, and it came back in a matter of seconds, where normally he may have got a call from the DBA saying, hey, you know, you just kind of have an impact on our data warehouse, so we need to kind of, you know, get that little call you don't want to get from the DBA. So anyway, in short, I think what you end up with is you end up with happy users, you have the happy DBA, nobody's getting phone calls. It makes for a happy life, at least for us consultants anyway. So with that, the next steps that we have are look at the current subject area that we built, to determine whether or not we want to just expand off of that. Also, the Eric and team is going to be speaking and discussing how the organization can take advantage of subject areas, and then we will be assisting them, hopefully we'll be assisting them with designing and building some additional subject areas so they can take advantage of this technology. And with that, I will turn it back over to Eric.
Thank you, Cathye. Can you see my screen? Yes, Cathye, can you see my screen?
Are you risk for, yes, I see the map.
Yep, okay. So as Cathye said, we're going to continue with subject areas. Also on the roadmap is spatial fraud analysis, tracking groups as they move, say, from Miami up the coast, and block smaller pockets of stores as opposed to large areas. So, you know, previously, if we saw somebody, you know, starting a fraud group in Miami and traveling through the state, we would block the whole state. Now after talking with Tim Blamis, we want to locate, you know, spatially how long would take them to get to Tampa. If it's 4 hours, we can, you know, leave Tampa open for those 4 hours until we think they can get there, kind of thing. So that's where we're headed with that. We're also working with machine learning, and which I will let Jason explain, as he is the technical guru of machine learning. So Jason, I leave it up to you.
All right, thanks. And so before we get into the machine learning, I thought I'd walk you all through how I traditionally work. My team, we build logistic regression models to reflect the probability of our transactions resulting in a financial loss. We've been using those for many years. They're explainable, which is great. So we know what's going into creating these scores. Our scores are generated real time when the transaction comes in and then used to decision those transactions. As far as what's going into those scores, or our X's based on the chart below, are things like consumer check writing history or check cashing history, history on the accounts we're seeing, current time characteristics like time of day or the transaction amount. Okay. As far as evaluating model performance, when we talk about risk models, the Kolmogorov-Smirnov test is typically what's used. The first thing we do is that we put our population that we're working with into score deciles. So each decile represents 2% of the population. Our decile 0, which we consider the bottom decile, represents the riskiest 2% of scores. And then as we move up in higher deciles, we're getting less and less risk. So when we get up to decile 49 for this example, that's our lowest risk 2% of the population. So our goal here is to push as much fraud as possible into the bottom decile or deciles, depending on what percentage of our population is fraud. But, you know, as George Box once said, you know, all models are wrong, some models are useful. So in our case, we look to make useful models. And one of the things to point out is we have degradation in model performance over time. That's something we're always going to see. So looking at the graphs, the light blue line represents the training data set. That's what the model learned off of. If we look at the bottom decile or decile 0 there, we see that about 68% of the fraud is captured by the model. But then when we look at our test data, that's another time period to see how well the model works over time. We see now we're down to 42% of the fraud being captured in that bottom decile. So the model's useful, not perfect. Okay, next slide. Okay, as far as building the model, the way we've done it is not ideal. The way it works is I will write a query and pull a bunch of transactions down from the data warehouse to my desktop computer. From there, I will sample all of the fraud transactions and then take a random sample of the good transactions and then load those back to the data warehouse where I have yet more queries to create attributes to feed into the model based on the consumer history. Then once I have all those attributes, the data comes back down to my desktop, I build the model, and then via a GUI interface, I'll deploy the model into production. Okay, next slide. So now we have some cool new tools. And in particular is Oracle Machine Learning. I've learned to really enjoy this one. So now I could do all my work on the cloud. The data's on the cloud as well as my machine learning tools. So it totally eliminates the need to move data to the desktop computer. And in addition, I could create automated jobs on the cloud. And below is sort of the circular flow that we've come to adopt. And so I'll start with creating a model build data set based on a bunch of queries. And then I could test a variety of different models on that data. So the types of models I've been using for our binary fraud outcomes is going to be random forest as well as neural networks. And then once I have a model that I like that serves a useful purpose, I'll create a job to basically pull down transactions, score them, and then I could share those scored transactions with the risk analyst so that they could further investigate. And then I'll continue to monitor the performance of these models to determine if we need to make adjustments or build new models. Okay, let's go to the next slide. So in OML, we have, again, the models I've been working with are random forests and neural networks. So our traditional models, they're still useful, they're just not perfect. So we're using these machine learning models to supplement the current ones. And in particular, we're using them to identify fraud ring activity. So the idea with these fraud rings is these can be multiple people hitting multiple locations. And what I want to do with machine learning models is identify them early so we could block future activity from them. And what I found is that our more complex neural network models are pretty useful in identifying this first wave of fraud for us. And let's go to the next slide. So I took a different approach to testing neural net models. The Kolmogorov-Smirnov statistic still works. It's not typically what you see when people are measuring the performance of machine learning models. So what I did is in this example, I tested various neural network models, altering the number of neurons and number of hidden layers here. I trained these models on 1 month of data. For example, it might be on July transaction volume. And then I'm going to test them on a future month of transactions because I know I'm going to have performance degradation. And I want to make sure that that degradation is, still useful to us. So when I do this testing, I'll do it on, let's just say, September transaction volume. So our model performance is really based on 2 factors. So the first factor is I want to look at the number of fraudulent transactions I could capture into the 1,000 highest risk transactions based on each of the models. And so what you'll see the bottom row in my grid there, where I have a neural network with 1 hidden layer and 1,000 neurons. If I take the riskiest 1,000 transactions, I see that I've got 15 instances of approved fraud there, which gives me an approved fraud rate of 1.62%. So that's showing me based on that one metric, that's the better model. The other metric I look at is the fraud dollars coming in from these fraudsters in the 7 days following that representative transaction. And that transaction really serves as an alert. So in this case, that third model there, we had $2,900 in fraud caught in the 7 days following. So in terms of our net loss rate, which is fraud dollars to approved dollars, we're looking at a 52.7% net loss rate. Okay, let's next slide. One additional measure of performance, I always like to look at actual fraud dollars avoided or fraud dollars captured in this case. So again, it's just proving out, is the model useful or not? So I'm just looking at the accumulation of fraud dollars by score decile here. And the dotted red line there is our cumulative fraud dollars captured in the training data set. So interesting thing to note there, that line is relatively flat. That's a good thing. What that's telling you is most of the fraud dollars are caught in that bottom decile. That's the highest risk decile. So that's great. Now, what's interesting about this data set is in the test period, we got hit with a fraud ring, and they hit us for a lot of fraud. Now, what's good is model looks useful. We're still getting a good chunk of the fraud dollars in that bottom decile, and a lot of them are, or a lot of the fraud is actually in the lower half of the deciles there. So it's showing that the model is working. Let's go to the next slide. So how does all this work? Well, the queries are written in OML, and they're set to basically run in the middle of the night. They pull all of yesterday's transactions to create the model features. Then the neural network scores the transactions and inserts the high probability of fraud transactions into a table accessed by risk analysts. They'll review the fraud alerts and create fraud cases to block future similar activity. So the performance right now is being measured based on the approved volume resulting in a net loss. The graph below shows you what we're typically looking at. So the black line represents on a weekly basis how many fraud alerts I'm generating. So it varies week to week. And the red line shows the percentage of the approvals in those alerts that are resulting in a net loss. And that performance also varies week to week. And let's go to the next slide. So luckily, I've had been able to work with Charlie Berger to really pull some value out of OML. So one of the beautiful things about this is pulling out some explanation behind some of these scores from the neural net. So typically neural networks are considered very black box. We feed a bunch of data in and then we get a prediction out, and we're not sure what goes into that prediction. But that's not good for regulators because they want to know why we decline somebody, and it's not good for risk analysts because if I tell them a transaction is high risk, they want to know why. So OML offers prediction details. I'm able to extract the top N features contributing to, in our case, a high risk score, and it also provides the values of those features. So the idea here is, based on like the grid below, is I'm showing, a probability of fraud that puts them at above average risk. The risk analysts want to know why. I could show them why. So at this point, I'm going to go ahead and hand it off to Chris Jacobson, and he's going to show us a good use case.
Hello, everyone. I'm Chris Jacobson. I manage the fraud investigations team. One of the functions of my team is actually a high dollar claims recovery group. What that group does is essentially pull the newest return checks, the high dollar ones, and they work with our clients to gather more information about the check writer to assist with collection efforts. In the past, we were using SharePoint to input everything. So essentially, we would pull a query, pull in all of this information, and manually key everything into SharePoint. And then once we would have payments come in on specific claims, the analyst would have to go in and enter all of the payment information manually. It made it difficult in reporting because I was kind of restricted to how quick the analyst would update the information. And also I was just basically pulling everything and manipulating everything with Excel. So in the past year, we've migrated to the Oracle Apex solution. So I wanted to share how we've had some success with this tool. In this example, this is our fraud load. So essentially now where I talked about how we would pull a query and have to manually enter everything into our database, we can now do it at a click of a button. So our development team created all the SQL behind the scenes for us. I can simply specify the date of which checks I want to pull in, and then I can click the button, load high dollar claims, and it's going to behind the scenes run those queries to pull in all of the claims that my team will be working on. As you can see, we have a few other claims that we work on as well. And we can also update these claims. So as they receive payments within our system, I can again specify the date, and I can click that update reviewed claims button, and it's going to update everything with payments and all of the updates that have taken place with a specific claim. So here's our dashboard where we have some of the different options, and you can see the high dollar claims there in the middle. So you can click on any of these and get to our dashboard. And here's our list of claims that my analyst is working on, okay? So this already has everything inputted from our database into our tables. And we can actually filter this then, so we can filter it and show specific analysts. So if I have 5 analysts, they can only look at the things that they're wanting to look at. I can also specify if it was a closed case, or basically anything that I would want to that are within those claims. Okay, and if I click on the little pencil there, now I go into the individual claims, and this is where they can input any of their notes, any of their emails, and they can also add any attachments that they have. So again, they're working with our clients. They might get an invoice for a specific claim. They can input this into the attachments. So now management, if they have a question about a specific claim, they can go in, filter by that specific claim, and they can see all of the notes, all of the emails, any attachments that are associated with that particular check. Okay, and reporting is really easy too. We have that option within the dashboard where, again, once I load all of the information, I'm not relying on my analyst to go and update all of the information one at a time. I can just update everything, and I can quickly pull a report for management, and I know everything will be accurate because it's how it is in our system. Okay, with the investigations, now I'm working more investigations where it's not a specific check. I have different fraud groups that they'll have hundreds of checks with different aliases, different IDs, different accounts, everything. So I really keep a spreadsheet of all of those different information. The old system that we would basically just use our shared drive. So we would have different folders for each case. Within those folders, I would have every spreadsheet, every piece of video, everything that I would have associated with that case. And then I would have my email. So if I wanted to find different email correspondence, I can go search through my email. So not really good when the case gets passed over to another investigator or you're trying to compile all the evidence that you need for prosecution. So now we're using Apex in our case management database. So in this, when we create a case, it automatically creates a case number for our specific case. And as you can see here, we have all of these other ones already listed. Within this, we can, again, add in all of our notes. We can add in all of the emails. We may have a contact list with all of our law enforcement, loss prevention contacts. So now anybody has access to those within my team. It also has an attachment, so I can attach any video that I've obtained. I could attach spreadsheets if I wanted to. I have the suspects listed on there, and that's really helpful since they're not using their real names on the checks for the most part. Once we receive restitution checks years from now, we need to tie those to the original checks that were part of the fraud. So when you get a restitution check, in this case, Melissa Speedy Gonzalez, they weren't using those names on the check, so it's really hard to determine which checks those go back to. So now we can search within this database and tie it to the checks because we can upload all of the checks that we have associated with this group. So now once we have this query and we have all of these return checks that are associated with the group, we can load it into our database, and we can also search for those claims. So if we're starting a new case, we can search those claims to make sure they're not part of an existing case and a case that's already being investigated. Okay, and just for your reference, the Speedy Gonzalez case that we're talking about, he was arrested. He's awaiting a federal trial right now, and I'll be testifying in that case if needed. Okay, any questions?
So we do have some questions that have come in. I'm going to go ahead and read them. I'll let you all decide who wants to address them. This is from earlier. I'm assuming the tables, the data dimension tables were created in the database, correct? I assume that's for Cathye.
Yes, and let me give credit that I was not the one that did this. Someone else, our organization, Mark Thompson, did this. But yes, he did create the dimension tables in the database.
In the database, okay. Another is, what are the data set limitations? This is back from when I think Eric was talking about the data sets and what are the limitations you ran into with the data sets?
There is a number, I think it's a number of rows. I know we have a size limit of 50 gigabytes per person, but there's also a limit, I think, and it's 100,000 rows. Eric? Do you know, and I can get back to you on that one, the exact limitations on it.
the data set limitations. They had a question about that.
Mhm.
Yeah.
Okay. And another one, this is maybe for Eric and Jason and so forth, is explain and other ML, it's machine learning functionality. Is that available on the mobile app? Who wants to handle that? That may be a product question. But what do you guys know about that? Have you guys looked at doing that on the mobile app? Have you gotten to that at Certity?
I have not touched the mobile app at this point in time.
Okay. Brendan, in the interest of, since we have the benefit of having people on from product management, you want to take that? Can you unmute and take that question?
Totally. Absolutely. Can you hear me? Yes.
Yeah, we can hear you.
So from that perspective, you're not going to experience the same explain functionality that you're seeing in Oracle Analytics Cloud with Day by Day, our mobile app, but there is machine learning infused with smart recommendations based off of the most topical data pertaining to you and your colleagues. So you'll still experience the natural language processing where you can hit the mic and ask the questions of your data and have the visualizations created right then and there. But you won't have the same explain that you'd see with Oracle Analytics Cloud with that right click on an attribute or a measure.
It's kind of hard to right click. You can kind of simulate it on a mobile app. But
Exactly. But yeah, but great question. Still infused with AI and machine learning and smart recommendations. Even, for example, if you're walking into your office, let's say, or a specific location, you can have geolocation based data pulled up right on Monday morning as you're entering the office. You have the notification on Day by Day to provide you your dashboard.
Okay. Super. And I'll just remind people, if you can find the Q&A area down at the bottom, I have one more question to ask of them. If you have something else, sneak it in that you want to ask of our Certity people. And here's the next question, do you use unsupervised machine learning to find fraudulent patterns in data, akin to identifying and isolating business rules, per se?
So, interesting question. So, we're using supervised data. I've experimented a little with unsupervised data, working with support vector machines. Interesting thing that popped out of there is where we get into, and this is an anomaly detection. We see it's good volume that fits into that rare category. So far it hasn't worked out for me, but it's more of a function of what you're feeding into the machine learning. So I'm going to keep working on that.
Okay. And when do you think you all would be looking to include that? Is that something on the roadmap, or going to be a while, or what?
I would say it's going to be a while. To be quite honest, I have a whole lot of work ahead to do with all of this. And so, yeah, it's there. I just couldn't say when.
Sure. Fair enough. Any closing thoughts? I think we're done. Any other questions? I didn't see any other guys. Well, with that, I'm going to thank I guess the 4 of you, if I counted right, for sharing your experiences with Certity and Cathye from the Vlamis side. Thank you so much for sharing all of that. We're going to transition to our next topic. Thank you very much.
Thank you. Really appreciate having us.
Great.
Thanks.
All right. Let me